Video number 2. We're doing the osmoregulation part. What I need you to do is draw 3 boxes like this and 2 boxes like that. Up in your first 3 boxes, draw the best starfish you ever drew in your life. And the bottom 2 boxes, draw the best salmon you ever drew in your life. Label the first box normal, the second box rainy, the third box hot. And then what we talked about is you got a starfish, you go down to the beach, there's a starfish. The tide goes out. It's just sitting there in a tide pool. You go up and measure the salinity of the tide pool. What is it? Guess. You just learned it. The salinity of the tide pool is going to be 35 ppt. And then I got a starfish. Have you? Have you ever taken a knife? Have you ever cut it open? Have you squeezed the starfish's guts in a beaker? Analyzed the salinity of the starfish guts? Oh, you haven't? Oh, it's 35 also. Then, on your notes above that, it says rule of thumb. See, the rule of thumb is that water goes towards the bigger salt number. We're talking about osmoregulation. Osmo means osmosis. Osmosis is the diffusion of water. And water is going to go to the bigger salt number. So I'm going back here. Is there an osmosis problem? No, there's not. 35 and 35. Situation number 2. Classic day in Seattle. The tide goes out. It's raining. It's just raining. How's that going to change the salinity of the tide pool? We just learned it. You're right. It's going to make the salinity go down. It's going to be less salty. I don't know. Maybe it's going to be something like 30. And inside the starfish is still 35. So by the rule of thumb, which way will water go? Water goes towards the higher salt number. So what's going to happen is water is going to go into the starfish. It's going to go like this. What's going to happen to the starfish? You're right. It's going to start to swell up with water. Oh, when I was a young marine biology teacher, I was thinking about what am I going to teach the next day. I'm going to teach about osmoregulation. I lived all by myself in a little shack by Ray's boathouse. It was nighttime. I smelled low tide. I got it. I got an idea. I went down to Golden Gardens, and there at the boat ramp, there's the fishing pier that kind of goes out. I went there with my flashlight underneath the fishing pier. Gold mine! I found 8 starfish just stuck to the pier. I ripped them off the pier. I brought them in and I put them in the tank of joy. I said, all right, class, it's time to do the lab. I said, come up and get a starfish. Dry out the starfish as best you can. Weigh the starfish on a scale. Record the weight. Okay. I had a bucket of water, fresh water, right out of the sink. I said, put your starfish in the bucket. We left it in there for 20 minutes. What started to happen? Yes, water started rushing into it. Visibly, they were getting bigger and bigger and bigger. Yes. All right, take starfish out. Dry them off. Weigh them. And what did we find out? Yeah, they weighed more. We proved osmosis. Yes. But by the end of the class, they were all limp. They were all dead. See, what happened is so much water rushed into it, it started to rip apart their body tissues, and they died. That's why when you go to the beach on a really rainy day, you're not going to find the starfish in a tide pool. They can't be in a tide pool. They got to crawl out of the tide pool, and they got to clean themselves to a rock. Otherwise, water's going to keep on rushing into them, and they're going to die. Situation 3, it's a heat dome. It's hot. It's 106 degrees. There's low tide. What's the salinity of the tide pool? Yes, you're right. Water's going to evaporate. It's going to leave the salt behind. So it's going to be something like 40. Inside the starfish, it's going to be 35. By the rule of thumb, what's going to happen? Water goes towards the higher salt number. So water's going to leave the starfish. And it's going to go like that. It's just going to shrivel up like a raisin. And again, it's going to die. It's why you don't find your starfish in a tide pool on a hot day. They got to crawl out again, even though it's super, super hot. Osmoregulation, the first 3 situations. The next 2 situations, we're talking about salmon. We're talking about salmon in the ocean, and we're talking about salmon in the river. You know a little something about salmon. Salmon, they go out in the ocean. They live out in the ocean for 3 to 5 years, and they come back to the river. Now, salinity of the ocean, got it, 35 parts per thousand. Well, have you ever taken a salmon, cut it open, analyzed the salinity of the salmon guts? Oh, 15. You know what I'm going to ask you? What's going to happen? Well, what's going to happen is water goes to a bigger salt number. So water is going to leave the salmon like this. But the salmon's got to stay out there for 3 years. If water's always leaving it, what must the salmon do? You're right. The salmon's got to constantly drink water. Next. All right. It's been 3 years. The salmon's going to go to the Ballard Locks. It's sitting at the Ballard Locks. It goes over the salmon ladder. Now it's in Lake Union. Lake Union is the same as a river. Salinity of a river or a lake, 0. Inside the salmon is going to be 15. So by the rule of thumb, water is going to rush into the salmon. Oh no, the salmon wants to live. So what must the salmon constantly do? Well, if water's always rushing into it, right, it's got to go, it's got to go pee, pee, pee. It must constantly pee. Then in class, we talked about bears in Alaska. The bears in Alaska, they're just eating blueberries. They don't want to eat blueberries. Then all of a sudden, one of them stands up on its back legs. It smells. What does it smell? Yes, it smells the salmon urine. It runs to the river and follows the trail of the salmon's urine, and that's going to lead them to the salmon. Then the other thing, I got a minute left to tell this story. Another thing that I talk about in this class is Issaquah Salmon Days. There in Issaquah is the Issaquah Salmon Hatchery. And the first weekend of October, we shut down the town and we have a parade, a festival. It's called Salmon Days. And we celebrate the return of the salmon. And we all go to the river and we go, yay, you made it home. And these salmon, they look like hell. See, after staying in fresh water for somewhere between 3 to 5 weeks, all of a sudden their kidneys start to fail. And because their kidneys start to fail, they can't go pee anymore. So what happens to their body is it starts to swell. And as it swells, their scales pop off. Scales are the fish's body armor. So when it goes up next to a rock, it just rips their flesh. These salmon, they just have huge chunks of skin just ripped off of them. Hopefully, they go there and they lay their eggs or do something with their eggs. And then just like the starfish in this situation, so much water is going to go in, and it's going to start to rip their body tissues, they're going to die. And that's why the salmon die. It's not because they just laid their eggs. It's because their kidneys have failed, and so much water has gone in there to rip apart their body tissues. I got to end my video.